Okay, and so we have sales for the past 5 years are provided, and the question is, what is the mean absolute deviation for a 3-year moving average based on this forecast? So let's bring up Excel. Let's add our data in there. So we have year in sales, 1, 2, 3, 4, 5, and our sales were 460, 475, 490, 484, and 502. So what we need, though, because we need the mean absolute deviation, we need some forecast data. So we're going to do our 3-year moving average. And so I can't do it for anything until year 4 because I need 3 years previous to do it. So we'll just average out these 3. That gives me my 3-year moving average. So my prediction for year 4 would have been 475, and we can do it for year 5. So we have 2 years of data that we can do things. So let's find the mean absolute deviation. I am terrible with spelling. Deviation. Close enough. We'll call it good. So we need to do our absolute value and the difference between. Now it really doesn't matter if I take the since I'm doing the absolute value, it doesn't really matter if I take the forecast or if I actually take the real number first. It's going to give me the same thing. And so there's our deviations. And so then the mean average deviation is only going to be based on 2 data points. So let's average them together. And so our mean average deviation is 14. And just for the heck of it, why don't we do our percentage error? We can do that too. And actually that would be just the percentage error. And so we can do this guy minus this guy. Wait a second. Actually, I have that backwards because for the percentage error, it's all based on demand. So we need to do that in the correct way. So what we actually had minus what we predicted with our moving average. And then we're going to divide that by what we actually had. I want all that stuff to index. And so there, my percentage errors, we'll turn that into percentage, actually look at it. And so then our mean average percentage error is going to equal the average of these two. So 2.8% is the average. And we can also, might as well do the mean squared error. So there's the squared error. So we're going to have the absolute, or the actual, minus the moving average. And we will square that. And then, so we'll have the mean average, or actually mean squared error. You could probably have put this table together a little bit better, but just doing it off the cuff. So the average of those two is 221. Mean absolute deviation, what does that mean? That means on average every month I'm off by 14 sales. Percentage error, the mean absolute percentage error means that every month I'm off by 2.8%. The mean squared error, 221, doesn't really mean anything. I can just use it to compare against other data sets to figure out which one's the best.